Hi guys, let's start DP series. DP is nothing but dynamic programming. And in this specific video, we are going to learn first about memoization and tabulation. Memoization nothing but top-down method, and tabulation is nothing but bottom-up method. And in this, I'm going to explain about top-down, which I will even explain about time complexity and space complexity. And bottom up also I will explain about time complexity and space complexity. And first, let's take an example of Fibonacci number. In this Fibonacci number, we have 0, 1, and we take the preceding of the given number and add that both, and we get the succeeding number. 0 plus 1 is 1, and 1 plus 1 2, 2 plus 1 3, and 2 plus 3 5, and 2 plus 5 8, and 5 plus 8 13. And this is called Fibonacci number. And in the question we have used the function called f of n minus 1 plus f of n minus 2, taking the preceding values of two numbers and adding them, and we'll get the succeeding number. For that, we use the function called f of 5, f of 4, and f of 3. When we call the f of 5 recursion value, we'll get f of 5 minus 1 4, and 5 minus 2 3. And now for the f of 4 value, we have f of 3 and f of 2, 4 minus 1 3, and 4 minus 2 2. And for f of 3 we have f of 1, f of 2, and f of 2 we have f of 1 and f of 0. And in the code we even remember that we recall our functions when it reaches the n less than or equal to 1. When here in this case f of 1, we return our f of 1 value, and here in this case we return f of 1 and f of 0 value, and the addition of plus 1 and 0, we get the f of 2 function value as 1, and we return the value as 2 to the f of 3, and we return the value of f of 1 to the f of 3, and the addition of both we get 2. F of 3 value is 2, and we return the f of 3 value 2 to the f of 4 function, and we return the f of 2 value 1 to the f of 4 function. You will get doubt that why I haven't do this f of 1 and f of 0. And in DP we don't need such kind of recursion. Here in DP we store the value of the functions in a DP array, where we can get where the DP function is a set of minus 1 minus 1 minus 1, and we store the f of 1 value as 1, f of 0 value as 0, and f of 1 value as 1, f of 2 value as 1, and f of 3 value as 2. So when it comes to f of 2, in the DP array we have already f of 2 value as 1, so there is no need of doing this once more. So we just recall the 1 value to the f of 4, and the addition of the both 3, we get f of 4 as 3, and we send back this f of 4 value is equal 3 to the f of 5. And now let's go to f of 3. F of 3, if you see in the DP series, f of 3 value is already 2, so we don't need to do the recursion once again. So we just recall the value of f of 3 to the main function f of 5, and addition of the both 3 and 2, we get 5. So this is the Fibonacci number, where we use this DP for not doing the recursion for all the time. And the time complexity is O of n, because we do function once and next and once O of n times. We do the recursion for O of n times, so O of n. When it comes to space complexity, it is the recursion stack. Recursion stack is nothing but the memory allocation of the functions of the call stack, and O of n is nothing but the DP array. And so this is the method we use in the DP to store our data in a given array. And let's go to our code. To see the code, function int m vector DP, and I have taken the DP as a vector, and you can take as an array also. And I have terminated my recursion when the n reaches the 1 less than or equal to 1, return the n. And you have to remember that to know whether the given value is already had an recursion, we use this if function where the dp of n isn't equal to 1 minus 1 and return the dp of n. So if it was a new recursion, return the dp is equal to f of n minus 1 comma dp plus f of n minus 2 comma dp. So this is the function, this is the code that we use for the Fibonacci number, the identified number. And now the next, the tabulation form. Tabulation form is nothing but bottom-up approach. And the recursion, this is the top-down approach. We come from top to bottom. And this tabulation method, we come from bottom to up. See, to see the code, the same Fibonacci number, I'll explain. To see the code, to see the previously in this code, that base case is dp of 0 is equal to 0, dp of 1 is equal to 1. And we terminate here. So in this case, this is our base case, this is the main theme of this tabulation. You see the for loop, I is equal to 2, means 2 minus 1 is 1 and 2 minus 2 is 0, so this is our base case. And we use this as our base case to find out the Fibonacci number dp of I is equal to dp of I minus 1 and dp of I minus 2. So for this, the time complexity is O of n and space complexity is O of n, because we store an array dp, so the space complexity is O of n. In order to reduce this also, we have another idea. To see, in order to find this value, we need the I minus 1 and I minus 2 value. In order to find the next of the I value, we need the previous I minus 1 and I minus 2 value. In order to find the next I value, we need the previous I minus 1 and I minus 2. Here you can see a pattern. The previous of the ith value is the previous I value. And if you find the previous 2 of the ith value is the first previous of the previous ith value, preceding ith value. So you can see the pattern here. So in order to reduce the space complexity, we use a previous and previous 2 concept. We change the dp0 to previous 2 and dp1 as previous 1. Okay, and we even change this as current I, and we even change this as previous 2 and previous 1 and previous 2. So, and make sure you change these values as, and here in this code you even also add the current I is equal to previous 1 and the previous 2 as, sorry for the inconvenience, we have even changed this previous 2 as previous 1 and previous 1 as current I, because previous 1 is the current I, so the previous 2 is the previous 1. But I have said that the preceding value of the current I will become the previous 2, the previous 1 becomes the current I. So for this, the space complexity is O of 1. When it comes to interview, you have to show the linear form. So thank you. Please subscribe to our channel.